Hello and welcome to the Unit 4 Section 1 video on triangle basics. So up to this point we've talked about lines and we've talked about angles, but now we're going to actually start forming some polygon shapes. And polygons are straight edge shapes that have 3 or more sides. And of course the most basic of a polygon is a triangle having 3 sides. Triangles can be classified by their angle measures. So here we have 4 examples of how you can classify a triangle by its angle measure. You have an acute triangle where we have 3 acute angles that make up that triangle. You have an angle sitting here in the top, you've got one here on the bottom left, and you have here one on the bottom right. So you have your 3 angles within the triangle, and they're all less than 90 degrees. Then you have an equiangular triangle. These are triangles where all 3 angles are congruent. And there's only one case where you're going to have 3 angles that are all congruent in a equiangular triangle, and that is if all 3 angles are 60 degrees. Then you have a right angle, or a right triangle, I should say. And a right triangle has a right angle in it. So you have exactly one 90-degree angle as part of your triangle. And then an obtuse triangle is a triangle that has one angle greater than 90 degrees. So let's classify each triangle by its angle measures with example A here. So we're going to take a look at triangle EHG, which is right here, EHG. It's the big triangle that makes up the whole figure. Well, we have a 90-degree angle here where we have H. Okay, so since we have a 90-degree angle here, EHG is a right triangle. Now let's take a look at EFH. So EFH is right here. It's the left-hand smaller triangle. And we've got 2 angles that measure 30 degrees each. But we don't have an angle measure for this one. Well, if you know about linear pairs, we know that these 2 angles together have to equal 180 degrees. So if we subtract 60 from 180, we find that this angle measure is 120. And that is an obtuse angle, which makes this triangle obtuse. And then finally, the right-hand smaller triangle. Well, this angle is 60, and this angle is 60, so therefore this angle must also be 60, and that gets confirmed because we know the big angle here, angle EHG, is 90, and this part of it's 30, and if you subtract 30 from 90, this part must be 60. So we do indeed have an equiangular triangle here. Now let's classify triangles by side lengths. So we did angles just now. Now we can also classify it by its sides. So an equilateral triangle has 3 congruent sides. Okay, all 3 sides are the same length. An isosceles triangle has 2 congruent sides, but the third may not necessarily be congruent. And then a scalene triangle means that we have no congruent sides at all. So let's take a look at equilateral and isosceles. Can you see a relationship between these two? Well, if an equilateral triangle has 3 congruent sides and an isosceles triangle has 2 congruent sides, then we can say that an equilateral triangle is isosceles because it does meet the definition. It has 2 congruent sides. It just happens that the third one is also congruent. So we can conclude that all equilateral triangles are isosceles. But we cannot say the converse. We cannot say that all isosceles triangles are equilateral because that third side may not be congruent. So, all equilateral triangles are isosceles, but not all isosceles triangles are equilateral. All right, let's take a look at some examples of classifying by side lengths. So let's first look at ABC. ABC is this left-hand smaller triangle. Well, we know that this side and the left side and the right side are congruent. So if this side's 15, this side must be 15, and the bottom is 15, so we have an equilateral triangle. For B, we're looking at ABD, which is our big triangle. Well, this one's 15, this side's 18, this side is 15 plus 5, which is 20. All three sides are different lengths, so this would be scaling. And then finally, for ACD, this length is 15, this length is 5, this length is 18. They're all different, so again, we have a scaling triangle. Now that we have classified by angles and sides, let's do both in these examples. So, let's classify by angles and sides. So for A, we have an obtuse angle, which means that this is going to be an obtuse triangle. And we have two sides that are the same, but the third one is not. So it is isosceles. So this triangle is obtuse isosceles. For B, we have a right angle in here, so it is a right triangle. But all three sides are different, so it is right scaling. For C, we have all three angles acute, so it's an acute triangle, and all three sides are different, so it is acute scaling. And then finally, for this one, all three angles on the inside are acute, but two of the sides are the same, so it is acute isosceles. All right, let's talk about angle relationships in triangles. Interior angles are angles that are located inside a triangle. An interior angle is formed by two sides of a triangle. Okay, when we talked about those angles when we were classifying using the angles of a triangle. You can also have exterior angles that are located outside of a triangle. Now these angles are formed by one side of the triangle and the extension of an adjacent side. And you see that here in this figure. We extend one side to create the exterior angle that goes with the one on the inside. Every interior angle has an exterior angle that makes up a linear pair. So let's identify our interior and exterior angles here. So we have interior angles, which are 1, 2, and 3, and exterior angles, which are 4, 5, and 6. Now we do have linear pairs here, and this is how we are going to write the linear pairs, because we know that they add to 180. So I'm going to write the measure of angle 1 plus the measure of angle 4 is 180 degrees. We can also say the same for angle 2 and angle 5. They add to 180 degrees. And the measure of angle 3 and the measure of angle 6 also add to 180 degrees. So you see how we're using some of the concepts from the previous units as we continue to move forward. This is a common theme in geometry. You're going to use a lot of the things that you've already learned as we move forward and learn more concepts. All right, so this brings us to the triangle sum theorem. And the triangle sum theorem states that the sum of the measures of the angles of a triangle is 180 degrees. You may have figured that out when we looked at the equiangular triangle. An equiangular triangle, all the angles are 60 degrees. You have 3 angles in a triangle, hence the name triangle. That's where the term comes from. You have 3 angles. There are 3 of them, so triangle. And you have all 3 being 60, so 3 times 60 is 180. So if we know that the sum of all the measures of the angles of a triangle is 180, we can use that to do things. So let's look at some examples of this. We're going to use the triangle sum theorem to find the measure of angle A in each of these examples. A is labeled for us in each one of these. So if we know that the sum of these are going to be 180, we're simply going to add them. 40 plus 6x plus 4 plus 7x minus 7 equals 180 degrees. So now we're going to combine our like terms. We got 6x plus 7x, that gives us 13x. 40 plus 4 gives us 44, minus 7 gives us 37. And then we subtract 37 from each side. That gives us 143. And then we divide by 13, which gives us x equals 11. But we're not looking for x alone, we're looking for a. So to find the measure of angle A, we simply plug in our value for x. So we have 7 times 11 minus 7, which gives us 70 degrees. All right, let's take a look at example B. Well, we have these 2 angles. We know this one's 90, so again, we're just going to add them all up. We got 90 plus 4x plus 6 plus 10x equals 180. 4x plus 10x gives us 14x. 90 plus 6 gives us 96. We subtract 96 from each side, and that's going to give us 84. And then we divide by 14, and we end up with x equals 6. So to find the measure of angle A, we're going to substitute our value of x in. So we got 4 times 6 plus 6, and that's going to give us 30 degrees. For example C, we have to use some previous knowledge. So we know vertical angles are congruent, so we know that this angle has to be x plus 70. For this one, we know that these two form a linear pair, so 180 minus 110 gives us 70 degrees for this angle. So now we can add these things up. You've got x plus 70 plus x plus 70 equals 180. So we've got 2x plus 140 equals 180. Subtract 140 from each side and you get 2x equals 40. Divide each side by 2 and x equals 20. Finding angle A is fairly easy because it's just x, so the measure of angle A is 20 degrees. And then finally, example D here. Again, we know vertical angles are congruent, so we got 9x plus 3 here. So we can add up our angles in the triangle to make 180. So we got 9x plus 3 minus 5 plus 5x plus 70 equals 180. So 9x plus 5x gives us 14x. 3 minus 5 gives us negative 2. 70 minus 2 gives us 68. Subtract 68 from each side, we get 14x equals 112. Divide each side by 14, and we get x equals 8. So the measure of angle A is going to be negative 5 plus 5 times 8, which is going to be 35 degrees. Now let's do a little application. So for example 5, we're given a map of France that is commonly used in the 1600s that was significantly revised as a result of a triangulation land survey. The diagram shows part of the survey map. Use the diagram to find the indicated angle measures. So on this map, we're asked to find NKM. NKM is right here. So it is the third angle in this triangle. Well, we know that the sum of angles in a triangle equal 180 degrees. So we know that 88 plus 48 plus the angle that we're asked for has to equal 180. So we will write it that way. 88 plus 48 plus the measure of NKM, which is what we're asked for, has to equal 180. Well, we add those together, we get 136 plus the measure of NKM equals 180. And then we subtract 136 from each side. And that's going to give us 44 degrees. So what I suggest you do here is we go ahead and start labeling our diagram as we get some of these angle measures. So this is going to be 44 degrees. This angle is congruent to this angle. That's indicated. So I'm going to go ahead and put 44 in here as well. Now we're asked for JLK. JLK sits right here. Well, we know that the measure of JLK is going to be this angle plus the 70 plus this angle, which we also do not know. But we can find JKL because we have 44, we have 104, and we know adding this one along with those two has to give us 180 because we have a straight angle here. So what we will do is we will go ahead and find what the measure of JKL is. So we know that it's going to be 44 plus 104 plus the measure of JKL equals 180 because of it being a straight angle. So 44 plus 104, that's going to give you 148. And we subtract that from 180, we get the measure of JKL equals 32 degrees. Now, again, that is not the angle we're looking for. That just gives us one of the angles we need to find the third angle we're looking for. So now, we have 70, we have 32, we just need the third one, so we're going to add these together to get 180. 70 plus 32 plus the measure of JLK equals 180, since they make up the interior angles of a triangle. 70 plus 132, 70 plus 32 gives us 102. And then we subtract 102 from each side, and we get that the measure of JLK is 78 degrees. So we have 78 here. And then finally, we need to find the measure of MJK. MJK sits right here. So let's talk about it in the figure before we scroll down. Well, we've got this side angle, this side angle. We're just missing the third. So 104 plus 44 plus MJK is equal to 180. So I'm going to write that down here. So we have 104 plus 44 plus the measure of angle MJK is equal to 180. 104 plus 44 is 148. Well, this sounds familiar, doesn't it? It turns out we're doing the exact same math that we have just above, which makes it easy for us because we don't even have to think about doing the math here because we've already done it. 180 minus 148 gives us 32 degrees. Okay, the last concept I want to cover in this section is the exterior angle theorem. The measures of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So what this means is, say angle 4 here, the measure of angle 4 is going to be equal to the sum of the two remote interior angles. So we're not doing angle 1 because that's right next to it. We're going to do the other two. So angle 2 plus angle 3. And we can do that for our other two exterior angles. The measure of angle 5 is the measure of angle 1 plus the measure of angle 3. And the measure of angle 6 is equal to the measure of angle 1 plus the measure of angle 2. So you're going to take the exterior angle, go to the one next to it, and then pick the two that are opposite from it. And you'll do the sum of those. So let's take a look at our last few examples. Starting with example 6. We're going to use the exterior angle theorem to find the measure of angle R. Well, we know that 86 plus R is going to be equal to 116 from the exterior angle theorem. So the measure of angle R plus 86 equals 116. Subtract 86 from each side, and you get that the measure of angle R is equal to 30 degrees. For example 7, we have our two remote angles here. I have our exterior angle here. So we're going to find x first. So 10x plus 2 plus 56 is going to be equal to 20x minus 2. So we combine our like terms here, get plus 58. And I'm going to go ahead and move things all in one go. So subtract 10x from each side, you get 10x on this side. Add a 2 to the other side, you get 60. Divide each side by 10, and you get x is 6. Now we're asked to find HPQ. HPQ is that exterior angle. So we are going to do the measure of HPQ by substituting in 6 for x. And when you do, and you do that math, you end up with 118 degrees. For example 8, we have our two remote interior angles, and then we have our external angle here, our exterior angle. So we've got 2x plus 3x minus 24 equals 4x plus 11. Again, we'll solve for x first, so we got 5x minus 24 5x minus 24 is equal to 4x plus 11. Subtract 4x from each side, you get x on this side, add 24 to the 11, and that's going to give you 35. Now we're asked for our angle W. So we go over here and find that. It's going to be 3 times 35 minus 24. And when you do that math, that's going to give you 81 degrees. And then finally, for example 9, we have our two interior angles here, our exterior angle here. So we have 2x plus 12 plus 61 equals 11x plus 1. So we have 2x plus 73 equals 11x plus 1. I'm going to subtract 2x from each side, so that gives us 9x here. Subtract 1 from each side, that gives us 72 here. And when we divide each side by 9, you get x is 8. Now we're asked to find angle Q. So we're just going to plug in x being 8 and do that math, and you're going to get 28 degrees. So that finishes off this section on the introduction to triangles here, where we talked about triangle basics, classifying triangles by their angle measures, by their side lengths, and then finally some angle relationships that we have in triangles. In the next section, we're going to expand and talk about triangle inequalities, see what we can do with some side lengths, and see how we can relate side lengths to angle measures, and we'll delve a little bit deeper into that.